Average rate of change. So let's review slope of lines from our Algebra 1 days. So when we're given a graph like this, we can draw a slope triangle. Remember, slope is always the rise over the run. So this is 2 blocks up and 3 blocks over. But we notice that the line is headed down from left to right, so we know it's a negative slope. So our slope here would be negative 2/3. Remember, it's always the rise over the run, the change in y over the change in x. And if it's going down the page, it's a negative. This next line is headed up the page from left to right, so we know it'll be a positive slope. And if I draw in my slope triangle between these 2 points, I can count 1, 2, 3, 4 blocks across, 1, 2, 3, 4, 5 blocks up. And it's always, again, rise over run, change in y over the change in x. So slope there is 5/4. This line is flat. It's horizontal. It does not have any change in y, so the slope here is 0. Horizontal lines have a slope of 0 always. All right, if we're given 2 points, we have to remember our slope formula from our Algebra 1 classes. Slope formula says the change in y divided by the change in x values. Doesn't matter which one you make, x1, y1, and x2, y2, you just have to be consistent. So I'm going to start with the second coordinate pair for the y values. I have to start with the second coordinate pair for the x values as well. Be careful with your negatives. So we get negative 10. In the bottom, this is really negative 5 plus 9 because the minus and minus. So 9 minus 5 gives us 4, and we could reduce that to negative 5/2 for our slope there. So formula, find the difference in the y values divided by the difference in the x values. And then if possible, we always need to reduce our fractions. We always got to check for it and see. All right, same idea, new problem. Oops, x1, y1, x2, y2. So find the difference in those y values. Negative 4 minus the negative 1 divided by the difference in the x values. So negative 7 minus 2. So negative 4 plus 1 over negative 9 would be negative 3 over negative 9. The negatives divide out, and 3/9 reduces to 1/3. So positive 1/3 for our slope there. One more. So again, subtract the y values. 3 minus negative 5 will become 3 plus 5. Negative 1 minus the negative 13. So again, minus and minus goes to plus. So it's really 3 plus 5 and negative 1 plus 13. So we get 8 over 12, both divisible by 4. So if I divide by 4, it brings my slope down to positive 2/3. All right, so for linear functions, it's called the slope because it's constant. It's always the same amount up and over to move from point to point. That's what makes it a straight line. For nonlinear functions, curves, the slope changes between different pairs of points. Because of this, we can't find a slope, so we find the average rate of change. The average rate of change of a function between 2 points is the slope of the line that passes through these points. This is called a secant line. The formula for the average rate of change of a function on the interval from a to b, so realize those are both x values, that's an interval. They're telling you from left to right between a and b. So we would evaluate the function for b to find its y value, evaluate the function for a to find its y value, find the difference in those y values, and divide it by the difference in the x values. So it's the exact same formula, it's just now we've got to plug in the first x value to figure out what its y value is, then plug in the second y value to the function, the second x value into the function to find its y value, then we can find the difference in the y's divided by the difference in the x. So we don't have 2 coordinate pairs, we're given an interval, which was 2 x values that were trapped between, and we've got to find their corresponding y values so we have the coordinate pairs. So if I'm given a graph, I can just read them off. So this interval is between negative 2 and positive 1. So if I go to my graph to where x equals negative 2, here's an x value, negative 2, so I got to drag up and down to where it meets the graph of the function, graph of the parabola, right here. So this is a positive 1 for y. So negative 2, 1 is that first coordinate pair. And then if we go to the graph where x equals 1, Here's x equals 1. Let me see where it meets the parabola right down here. So let's count and see what that is. 2, 3, 4, 5, 6, 7, 8. Negative 8. So at positive 1, the y value is negative 8. So here's x1, y1. Here's x2, y2. And now we can use our slope formula. So negative 8, take away 1, divided by 1 minus the negative 2. So we get negative 9 divided by 3, because that was really 1 plus 2. Minus minus goes to the plus. And so we get a slope of negative 3. Same thing, new interval. So now x is 0, between 0 and 4. So when x equals 0, that's the y-axis here, and it meets the parabola right here. So that is 1, 2, 3, 4, 5, 6, 7. Negative 7. So when x is 0, y is negative 7. So our first coordinate pair is 0, negative 7. And then when x is 4, right here, meets the parabola right here at positive 1. So y is positive 1 when x is 4. So that's our second coordinate pair, and we can plug them into our slope formula. So change in y, find the difference in the y values divided by the difference in the x values. So remember, this is really 1 plus 7, because the minus is minus. So we get 8 divided by 4, which gives us a slope of positive 2. So the first interval they gave us between negative 2 and 1 was on the decreasing section of the parabola. So we had that negative slope. And then they were asking between 0 and 4, and most of this is the increasing section. So we came out with an average rate of change of positive 2. All right, if all we're given is the equation, we've got to plug those values in to find their y value. We can't just read it off the graph. So the first x value I'm given is negative 1. Remember, these are both x values. This is not a coordinate pair because it's in brackets. It's an interval. 2 x values. They want to know on the graph between the x values of negative 1 and 2 what the average rate of change will be. So I need to figure out what is the function equal when x is negative 1. So remember, that negative in front of x squared is like a negative 1. I've got to square my x and then multiply it by negative 1. So negative 1 squared will be positive 1, but then we multiply by negative 1. We will get negative 1 minus 6 minus 14. So that's going to give us negative 21. So that first coordinate pair, negative 1, negative 21. Second x value they gave me is positive 2. So now I've got to evaluate the function for positive 2. So 2 squared would be 4 times negative 1 gives me negative 4 plus 12 minus 14. Well, negative 4 plus 12, or 12 minus 4 would be 8. Minus 14 gives us negative 6. So our second coordinate pair is 2, negative 6. And so if we plug into our slope formula, find the difference in the y values divided by the difference in the x values. Again, it becomes negative 6 plus 21, 2 plus 1 in the bottom. So 21 minus 6 would give us 15. And the bottom 2 plus 1 is 3, so 15 divided by 3 gives us 5. So the average rate of change for the interval from negative 1 to 2 is positive 5. All right, same idea here. We've got the x value, but we need to know what is its y value, because remember, this is an interval. These are both x values that they give us here. We need their y values, and that's why we have an equation. The equation of the function is what we use to find an output or a y value. So I'm going to take my x, plug it in for all of the x's, and follow the order of operations to figure out the output or the y value. So I got to do my exponents first. So 4 squared would be 16 times 2 is 32. So 64 minus 32 would be 32. Minus 36 would be negative 4 plus 1. We should get negative 3 there. So that first coordinate pair will be 4, negative 3. Then we got to do it again for when x equals 7. So if I substitute 7 into my equation and do the math, so 7 cubed, 343. 7 squared would be 49, times 2 would be 98, minus 63 plus 1. And you will have a test on this calculator, so I'm going to use the calculator to help me make sure I don't make any silly mistakes here. So we've got 343 minus 98 minus 63 plus 1, so I get 183. So slope formula, change in y, so 183 minus the negative 3 divided by 7 minus 4. So that's really 186 divided by 3, and we'll get 62. 3 would go into 18 6 times, and then 3 into 2 2 times. So our average rate of change there would be 62. All right, so we would follow that exact same process for 11 and 12. So pause the video, try those, and see if you're able to successfully solve those two on your own. You should have gotten for number 11 an average rate of change of 1/4, and for 12 it was 1/6. If you're not able to successfully get those, please ask in class and we can go over it. But 13 and 14, so applications here. In 13, a company's total cost, C of x in dollars, to manufacture x units is given by that function. Find the average rate of change of the total cost for the first 200 units manufactured. So let's first of all find out how much it would be if we don't manufacture any at all, meaning, just the base cost we have before we even start producing. And we're going to see that's 1,200. So our first coordinate pair will be 0, 1,200. And then we need to find out what it costs to manufacture 200. So you should get 11,200. So our coordinate pair there is 200, comma 11,200. And so if we plug into slope formula, we'd have 11,200 minus 1,200 over 200 minus 0. So we'd end up with 10,000 divided by 200, which will give us 5. Or sorry, 50. Canceled out. One too many zeros. 100 divided by 2 would be 50. So $50 per unit is how much it costs to manufacture for the first 200 units that you're manufacturing. All right, 14. A ball is thrown straight upwards so that its height in feet is given by the equation shown here, where t is time in seconds. Find the average rate of change in the height of the ball from when it reaches its maximum height until it reaches the ground. So first of all, maximum height would be the vertex. So you've got to remember some Algebra 2 things here. This is a quadratic function in standard form since it's got the t, the linear term here. So to find the vertex in standard form, you've got to do the opposite of b divided by 2a. So the opposite of b is negative 80. 2 times negative 16 would give me negative 32. Those are both divisible by 16, and I can cancel out the negatives. So I can bring it down to 5/2. So the x-coordinate of the vertex is 5/2. So then I need to substitute that into my function to find its corresponding y value. And so we get 100. So the vertex has coordinates 5 halves, 100. The second thing they talk about is when it reaches the ground. So that would be an x-intercept. So to find x-intercepts, we replace the h of t or the y with 0. This one is factorable. It has the GCF of 16t. And I'm going to take out negative 16t actually to keep that leading coefficient positive. So it factors like this. And then we're able to divide out that a value of the negative 16 and use zero product property to solve and realize either t would have to equal 0 or t minus 5 would have to equal 0, which means t equals 5. So our second coordinate pair, it's going to hit the ground after 5 seconds. So our second coordinate pair would be 5, 0. And then to find our average rate of change, difference in those y values divided by the difference in the x values. So we get negative 100, 5 is, oops, common denominator of 2, not 5. So 2 times 5 gives me 10 over 5. 10 over 2, I'll get this. 10 over 2 equals 5, but would have the common denominator with the 5 halves. So we have negative 100 divided by 5 halves, but we don't divide one by a fraction. Instead, we'll multiply by the reciprocal. So we would multiply by 2/5 rather than dividing by 5 halves. So 100 divided by 5. Somewhere I dropped a negative. Oh no, I'm sorry, I'm good. Thought I made a mistake. 100 divided by 5 gives me 20, times 2 would be 40, so it'll be negative 40. Because we're talking about the ball is coming down. It reaches maximum and it's coming down. So negative 40 feet per second would be its average rate of change as it's falling back down. All right, so average rate of change, slope for curves.